Greetings and welcome to our last video in this series, 8.6, the quadratic formula. So we have a property of the quadratic formula that for any quadratic equation in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0, there are two solutions. First solution is x equals negative b plus the square root of b squared minus 4ac all over 2a. And our second is negative b minus the square root of b squared minus 4ac all over 2a. So it doesn't matter what our quadratic equations is. If we plug in what a, b, and c are into these two equations, we will get our solutions for x. Now, we don't usually go through any of our proofs, but this one is quite clever, I think. So let's start off with ax squared plus bx plus c equals 0. So the first thing I want to do is move over the c to the other side, the right-hand side. Then I want to complete the square. I want to divide by a, so I want that coefficient in front of the x squared to be 1. So I'm going to divide everybody by a. Now I'm left with x squared plus bx over a equals negative ca. I'm going to complete the square, so I take the coefficient of my linear term, which is ba, and I divide it by 2. That gives me b over 2a. Then I square it to figure out what I'm going to add to each side. So I have b over 2a squared, which is b squared over 4a squared. I'm going to add that to both sides. So now I have x squared plus bx over a plus b squared over 4a squared equals minus c over a plus b squared over 4a. But the left-hand side, by design, is a perfect square of a binomial, which is x plus b over 2a, all squared. By finding the common denominator, adding like terms, the right-hand side becomes b squared minus 4ac all over 4a squared. I take the square root of both sides. Now I'm left with x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. Where did the 2a come from? 4a squared, the square root of 4a squared is 2a. Now I just need to move the b over 2a over to the right-hand side, giving me minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. But they have the same common denominator, so I can combine them, giving me with my final solution, my quadratic formula of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. To me, I think it's pretty clever to come up with this just from a starting point, using all of the math that we've learned thus far to come up with a nice equation formula for us to solve any quadratic equation. Using our quadratic formula, let's solve x squared minus 4x minus 5 equals 0. Now, yes, I know you could probably factor this, but let's use this new tool to solve for what x is. So the first thing I need to figure out is what a, b, and c values are. A is 1, b is negative 4, c is negative 5. Plugging that into my equation, my formula, I get x equals the negative 4 plus or minus the square root, negative 4 squared, minus 4 times 1 times negative 5 all over 2 times 1. That leaves me with x equals 4 plus or minus the square root of 16 plus 20, because negative 4 squared is 16. Negative 4 times 1 times negative 5 is plus 20, all over 2. That's x equals 4 plus or minus the square root of 36 all over 2. Square root of 36 is 6, so it's 4 plus or minus 6 all over 6. But then we have to break it apart into two equations because that's plus or minus. So it's 4 plus 6 over 2 and 4 minus 6 over 2. That gives us 10 over 2. 4 plus 6 is 10. 10 over 2 is 5. And 4 minus 6 over 2 is negative 2 over 2. So our final solutions are 5 and negative 1. Yes, I know maybe factoring for this problem would have been faster, but it does show that the quadratic formula can be used on these equations. Let's solve x squared minus 9. Now yes, you could probably move the 9 over to the square root of both sides and it's a lot faster, but here, let's use quadratic formula just to see what happens. Alright, so x squared minus 9 equals 0. A is 1, B is 0, C is negative 9. I'm going to plug it in. Remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So 0, so it's x minus 0 plus or minus the square root of 0 minus 4 times 1 times negative 9 all over 2 times 1. That gives me 0 plus or minus the square root of 0 plus 36 all over 2. That gives me 0 plus or minus 6 all over 2. Well, that's really 6 over 2 and negative 6 over 2, which our answers are 3 and negative 3. Now the previous examples were pretty simple and we could have used other techniques to solve for our variable. But when you start working with fractions or decimals, it becomes a little bit harder and the quadratic formula really comes in handy. X squared plus 2x equals 3 halves. Well, we're going to move the 3 halves over to the left-hand side, so it becomes x squared plus 2x minus 3 halves. Let's figure out what a, b, and c are. And what I did was I went ahead and got rid of my fraction by multiplying everybody by 2. So it became 2x squared plus 4x minus 3. A is 2, b is 4, c is negative 3. Plug it into my formula. X equals negative 4 plus or minus the square root of 4 minus 4 times 2 times negative 3 all over 2 times 2. So x equals negative 4 plus or minus the square root of 16 plus 24 all over 4. No, I can't reduce yet because that's plus or minus, so I can't just cancel out the 4's. Now I have x equals negative 4 plus or minus the square root of 40 all over 4. Simplifying my radical, I have negative 4 plus or minus 2 square roots of 10 over 4. I can factor out a 2 in the numerator and simplify, giving me negative 2 plus or minus the square root of 10 all over 2. So my answers are x equals negative 2 plus square roots of 10 all over 2 and negative 2 minus square root of 10 all over 2. Now I'd like to see you factor that original problem to see if you could come up with the real solutions of negative 2 plus or minus square root of 10 all over 2. It would be pretty difficult. So this formula that we have in our fingertips now is really pretty powerful. Here's a problem I'd like you to do for your video problem for this set. Complete this problem, turn it into class our next session. So the first thing you will need to do is to FOIL what x plus 2 times x minus 1 is, get it all over to the left-hand side, figure out what your a, b, and c values are, plug it into your quadratic equation, and then solve for x. So here's the quadratic formula once again just to help you out. So again, I would like this problem for next class session. That's it for this video and that's it for this series. So until next time, be seeing you.